Hello once again, all you Algebra A students and rando people from the internet. My name is Mr. Winchell, and today I am tasked with trying to teach you about dividing radicals. Today, hopefully by the end of these notes video, you'll be able to divide radicals and do this super fancy thing called rationalize the denominator. So buckle up, go to that YouTube channel, like and subscribe to your favorite math teacher. And let's start with some intros and refreshers. All right, so we got to go back to the basics for today to make any amount of sense. Today is all about division, aka your favorite thing called fractions. In a fraction, top number, that's our good old numerator. Bottom number is the denominator. Always have to spell it out. Denominator. I bet it's actually right there to my left. Cursive, a lefty. So yeah, we got a numerator in the top, denominator in the bottom. All right, so something else that's going to be super important for today, do not forget that anytime I have a radical and I'm multiplying that radical by itself, it actually gets rid of, I almost just wrote x, it gets rid of the radical. This works for variables, this works for numbers, this works for just about anything underneath a radical, okay? So that's going to be super, super important for today. Next, the identity property. It's actually not as difficult as you think. 3 divided by 3, awesome, that's 1. How about x divided by x? That too is also 1. How about radical 5 divided by radical 5? Now that is also 1. However, we're going to run into this little bit of an issue when it comes to radicals and fractions, because if there was anything that was super important to remember for today, it's this phrase that you're going to hear your math teachers say approximately a cajillion times, which is you can't have a radical in the denominator of a fraction. So our job is to learn, well, if that can't happen, how do we fix it? Well, it's actually a little easier than it sounds. All you're going to do is multiply by. Now, I wish there was actually a video here. I'm using super vague air quotes. 1, okay? But remember, any number except 0. Sorry, 0, can't join the party. Any number divided by itself is equal to 1. So we're going to kind of cheat the system here to get rid of those radicals in the denominator. And this process is called rationalize. In fact, if you want to sound super fancy today, we are going to learn how to rationalize the denominator. If you want to impress your friends, say, hey, I'm going to rationalize the denominator. And they'll probably say you're a nerd, but hey, you're a nerd that knows how to rationalize. So let's see what we need in order to do this. Oh, yeah, bro, this property is just mad dope. Oh, yeah, another radical property. Let's not forget, actually, that we have a property that looks kind of like this. This is for multiplication, where you could kind of separate things so that they get their own radicals. Well, turns out you can use the same type of property for division, okay? So now it's actually super important that you remember that I can use this property both ways. So I can take a fraction that has a radical in the numerator and denominator and just chuck it under one big fraction. Now, when would you want to do this? Well, in this example here, I have radical 32 divided by radical 2. The big uh-oh is that I have a radical in the denominator. But wait, if I just put both of these numbers under one big radical, I would notice that I could simplify that fraction. Simplifying fractions has not gone away. So then suddenly that's radical 16. Now, if you remember, that happens to be a perfect square because the square root of 16 is a whole number, which is 4. Now, remember, our job is to simplify, yeah? So, what's simpler, radical 32 divided by radical 2, or simply just saying 4? I'll just answer that question. It's 4. So that would be an example of when I should try and put two things under one radical. Well, how about when you want to separate them, like when you go the other way? really, it's going to focus on you understanding your perfect square roots. Because radical 6 divided by 25, there's nothing I can really do with 6 divided by 25. But if I split up the radicals, then I'd notice that radical 25 is a perfect square. This means that it would simplify to radical 6 divided by 5. Now, it's really important to remember the sacred rule, which is you can't have a radical in the denominator, but it is also important to mention that radicals can be in the numerator. That is completely fine. You're just always going to want to simplify. It's like some kind of weird Harry Potter spell. Simplify! But that is the property that we are going to need to use for today. So let's see if we can learn the procedure for when we're dividing radicals. All right, it is time for you to put on your smarty pants because you are going to learn how to rationalize a denominator. The first step is take a look at your fraction and just try and figure out, should I split the radicals? Should I keep it under one giant radical? Like, are there any perfect squares? So try and simplify just as much as you can, okay? Once you do that, if there happens to be a radical in the denominator, then you're gonna have a bad time. So let's say that I had 2 divided by radical 3, okay? I have a radical in the denominator. This right here is a no-no. I can't keep a radical in my denominator. So what I'm gonna do is I'm going to multiply this expression by 1. Now that 1 is going to be radical 3 divided by radical 3. Now you're going to say to me, well, Mr. Winchell, didn't you just say that your denominator can't have a radical in it? Well, radical 3 divided by radical 3 is just 1. So I can actually use that to my advantage. So I'm going to go ahead and just multiply the numerator and the denominator by radical 3. Oh, hello there. Ooh, I didn't know that was an option. So when I do that, I'm allowed to multiply the numerators together. That would give me 2 radical 3. And then you're going to notice in the denominator that radical 3 times radical 3 would cancel the radical, and I'd be left with 3. In this example, you'll notice that my fraction is 2/3, okay? That cannot be simplified. And my radical in the numerator, that radical 3, also can't be simplified. So this is when I would be done. So really, when you're simplifying, you want to try and simplify your fraction or radicals. And number 4 is just, double check. Like, okay, so for instance, I'm going to give you guys a concrete example. Like, what if I had 4 radical 2 divided by 8? Our whole job is simplifying. So what I really need to do here in terms of simplifying my fraction is I'd have to simplify 4 divided by 8. Just because there's a radical 2 attached to it doesn't mean that our rules for simplifying have changed. This would simplify to radical 2 divided by 2 because 4 divided by 8 is just 1/2, right? That's 1/2. That has not changed. The other thing you really want to pay attention to is watch out for perfect square roots. If your radical that you're multiplying by is a perfect square, then it's actually just a whole number, just disguised under a radical. So now, that is our procedure for multiplying a denominator to rationalize it. So let's see some examples. All right, so we got some comically large fractions on this example page. Shout out to me, I designed this. So in my first example here, I have radical 4/7. Now, I have a property. Let's remember that if I have a radical in the numerator and a radical in the denominator, I can combine the radicals to under one radical, or I can split them up. And right here is where I would want to split them up, because I notice, and you guys hopefully notice this by now, that radical 4 is a perfect square. So I'll say that this is radical 4 divided by radical 7. Now, this is going to be great because that's going to simplify to 2 over radical 7. Now, you'd want to circle this, but you can't because there's a radical in the denominator. So what I'm going to do here is I'm going to rationalize. I'm going to multiply this by 1. Okay. Now, that 1 is just going to be the radical in the denominator over itself, because that's technically 1. Okay. So then I can just multiply fractions like I typically would even before this lesson. Hopefully you knew how to do that. I would get 2 radical 7 divided by 7. Because remember, radical 7 times radical 7 is just 7. This is that other property where if you multiply a radical by itself, it gets rid of the radical. And then I need to take a look at the fraction. 2/7, can't simplify that. Radical 7, no, that's fine. That's my final answer. All right? So in the famous words of DJ Khaled, another one. Radical 2 divided by radical 6. Okay, well, neither one of those are perfect squares, but notice that if I were to just put this under one big radical, I could actually simplify this to radical 1/3. Now, unfortunately, that's still a giant radical. So what I'm going to do here is I'm actually going to separate this. And this is, of course, when people forget that radical 1 is a perfect square. Okay, like 1 is a perfect square because 1 times 1 is 1. So this is going to give me 1 divided by radical 3. Now that's the issue. I can't have a radical in my denominator, so I'm going to rationalize. I'm going to multiply the numerator and the denominator by the radical that's in the denominator. I'm trying to use the problem to get rid of the problem. 1 times radical 3, come on now, that's just radical 3. And then radical 3 times radical 3 cancels the radical. I'm done. This is radical 3 divided by 3. Now, holy cow, you cannot say that radical 3 divided by 3, which is a different number, is 1. That doesn't make any sense. Only numbers over themselves, sorry, not 0, equal 1. So don't fall into that common mistake, all right? My last example, do I even have space for it on this page? Radical 3 divided by radical 2. Okay, well, neither one of those is a perfect square. I can't simplify 3 divided by 2. So I think my first step is I'm actually going to go ahead and separate the radicals, because now when I go to rationalize, I'm just going to multiply the top and the bottom of my fraction by radical 2. Now, this is the first example where we've had a radical times a radical, and that's totally fine. I can combine those radicals. That's this property. Actually, you're using all 3 properties that you've learned here. That's kind of fun. Remember, if I have 2 numbers under a radical, you can just sandwich them together and multiply them. So radical 3 times radical 2, that would be radical 6. And then radical 2 times radical 2, this is why we rationalize the denominator, would just be 2. Once again, I cannot say that radical 6 divided by 2 is like radical 3. I can't. They're actually different terms. So, believe it or not, I'm done here. So these are our first 3 examples of trying to rationalize the denominator. Let's see how much harder it can get. All right, 3 more problems separate you and me from this YouTube journey. 3 divided by radical 5. Okay, so there's no radical on the 3, so it looks like all we have to do here is rationalize the denominator. So I'm going to go ahead and multiply this fraction by 1, which is just the radical in the denominator over itself. So 3 times radical 5 would just be 3 radical 5. And then radical 5 times radical 5 is just 5. And that's it. I mean, this is just trying to rationalize this fraction. So I can't reduce 3/5. 5 is not a perfect square, nor is it simplifiable. I don't think that's a word, but we're done there. Haha, that was easy. All right, so we move on to the middle example. Radical 2 divided by 5, radical 3. Okay. So because there's that 5 in the denominator, I can't make this all like one big fraction. It actually wouldn't even help me if I did that. So I'm going to go ahead and try and get rid of the radical by multiplying by, and this is key, only the radical that's in the denominator. That 5, it might as well be dead to me because that does not determine rationalizing denominators, okay? So I will multiply the numerators. I'll get radical 6 divided by, now this is important, I get 5 times 3. Now, if you're wondering where that 3 comes from, remember radical 3 times radical 3 equals 3. The 5 was a coefficient, so it's still going to be multiplying here. This means that I end up with radical 6, that didn't change, divided by 15. And I get a lot of students that will try to simplify that. They'll be like, oh, yeah, 6/15. That's 3 divided by 5, right? Well, that is true. This isn't 6/15. This is radical 6 divided by 15. If they both had radicals, that'd be a different story. If they didn't have radicals, that would also be different. But you got to be careful and be mindful of what you're doing, okay? And then last but not least, our final example, 2 radical 5 divided by radical 50. Okay. What's really interesting, I won't say interesting, what's rather unique about this example is there's a ton of different ways that you can do this. You can start by trying to simplify 50 because I happen to notice that would have a perfect square factor. I could try and simplify the fraction. Actually, you know what? Why don't I do that? I'm going to say 2. Let's see here. Actually, yeah, I'll do it. Yeah, I'll do it just to show you guys. So radical 5 divided by radical 50 would be radical 5 divided by 50, which is radical 1/10. But I'm going to go ahead and split those up again so that they get radical 1 over radical 10. Okay, I'm doing this because, as people love to forget, radical 1 is a perfect square. So this 2 actually just stays up in the numerator. You could say like it's 2 times 1, but remember, I'm trying to simplify my life. So I'll get 2 divided by radical 10, okay? Just for the sake of consistency, this radical 1 here is, I'm just going to say is times 1. But now the issue is the radical 10 in the denominator. So I'm going to go ahead and rationalize this by multiplying both the numerator and denominator by radical 10, which means I'm actually multiplying by 1. So I'm not changing the value of the expression, but I'll multiply the numerators. So I'll get 2 radical 10. And then radical 10 multiplied by radical 10. I'm losing it, guys. My goodness. Would give me 10. It's at this point that I got a lot of students who would be like, oh, yeah, I'm done. Ha, 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 ha. And you'd be wrong, unfortunately, because you need to simplify. You need to reduce your fraction. The 2 divided by 10, no thank you. My job is to try and simplify here. So I'm going to say that that's 1/5. So my final answer is radical 10 divided by 5. Don't hit the control board. Nice. All right. So with that last example, that concludes the notes for today. So what did you learn? Well, you learned another radical property, dudes, where you can split a numerator and denominator to both have their own radical or shove them under one fraction. And you also learned a very important procedure called rationalizing the denominator. Okay. So once again, my name is Mr. Winchell. I hope you enjoyed this journey of going through the 1A video notes. If you have any questions, I'm sure your teachers are going to love making fun of me. So ask them for any guidance. But thank you guys for coming along on this radical journey, and I'll talk to you in the next video.